everything we're saying now?
Oh, I hear you guys all the time. You're right.
No, I'm talking about, do you really? Do you hear what we're talking about?
You guys talk all the time.
They don't hear us.
And stop copying other people's stuff.
Because we,
This is my left burner. I have my left
Oh,
burner.
whatever.
I was putting all the chemicals in and she was ready.
All right, so points, lines, and planes. Now, there is not a lot with this first section, so it should not take for all day to go through it. And I actually have a couple of really cool things. I have a couple of cool things to show you guys about geometry in space. Not like as in space, but as in real world. As we get going now, that we've got out of the algebra stuff, I don't want you guys to think that the algebra goes away. We're done with it. It's not. What's going to happen a lot of times now, it's not so much going to be writing equations and lines and things like that. It's going to be more often a geometric concept that has an algebraic take to it. For example, one of the things that we start to talk about today is a line segment. And we all know what a line segment is. We've all seen it. We've all worked with them before. Has endpoints, has some distance to it. And if I say that this whole thing is 32, and this much is x, and this much is 3x, what do you do to solve for it? Solve for the parts. What would you do? I know you can do this. What would you do? From here, this is really starting to frighten me, ladies and gentlemen. From here to the computer stand is 32 feet. I went this far, and this far is 3 times as much. How much is it? What do you do to figure out how far x is? I am. Let me try this again, a little easier. If how far is that? 10. Okay. 4 plus 6 is 10. So if this much is 10, that much is 4. 6. Okay. If that whole thing is 10, this is 2x, and this is 3x. What do you do to solve for x? Right, so what are you doing? You're doing 2x plus 3x has to equal the whole thing, which is 5x is 10, and x is 2. Okay? It's the exact same thing. If this whole thing is 32, this much is x, this much is 3x, what's this together? 4x. Guys, it's a one-step algebra problem. If we're having problems with the one-step algebra, and you're recommended for geometry AP, you might want to switch classes. So like that. That's the idea of what I mean by the geometry comes back with an algebraic twist. Okay? So let's look at a couple of definitions. One of the first things that we deal with in terms of geometry is that we have to know where we are. We have to know where things are set up. We have to know how things work themselves out. Thanks, guys. You're the best. Remind me to get you something nice when it's your birthday. Which means it's not going to happen. So, what is a point? You know what? That's what most people say. What is it?
The closing point of the line.
Okay. All right. A point, believe it or not, the most generic way of labeling it out or describing it is any place in space. It's a place in space. It's some spot. It's the, you are here. Okay. When you talk about something in terms of that, obviously when you start thinking about how relatively small things really are in relation to how really large the universe really is, a point is the most singular thing that you can have. It's the smallest piece that there is. It's just a place. It's just one spot. Do you know how you label a point in geometry? I know you've seen this before. What do you use? That's when you start getting into multidimensional. Coordinates would be, when you're talking about a coordinate system, you're talking about an XY grid. A point has a specific placement, some X value, some Y value, because now it's placed into 2 dimensions. But when you're a point, you have no dimension. You're just labeled as a spot. And we use, when we're talking about points, we use capital letters. Point A, B, C. And we just call it point A. A lot of times it'll abbreviate. I know you've seen this. I believe this is 6th or 7th grade, just some very simple geometric terms. Okay. Like I said, it has no dimension. Do you guys understand what I mean by dimension? Like 1 dimension, 2 dimension, 3 dimension, and all that? What would a 2-dimensional object look like? A flat, what are you going to say? A what? Quite literally, a piece of paper. A piece of paper is a 2-dimensional plane. Your XY coordinate system is a plane. What's a 1-dimensional thing? What's on your paper? Lines. Lines are 1-dimensional. What's 3-dimensional? What's that? 3 sides, but think about it. Don't we live in a 3-dimensional world? 3-dimensional world is what we live in. It's something that holds volume, something that can hold stuff. It's when you start getting into things like that. A sphere, a ball, that's 3-dimensional. Up, down, in, out. Okay. What about 4th dimension? You ever heard of that? 4D?
I watched the movie and like it's spray mist
Yep.
and stuff.
Yep. It's, you guys ever see like the 4D movies at like Universal or anything like that if you go there? About 10, 12 years ago, my family went out and my parents took my brother and I out to California. We went and did that where we watched Shrek 4D. So we were watching the Shrek movie, and then all of a sudden you get that poof of water blowing at you, or like an air blows through, something like that. So it's the 3-dimensional of the immersion of it, but then something else happens, like your chair moves and you're doing all that other stuff. So with something like an IMAX movie, they have the movable chairs now, where with the 3-dimensional. So that's kind of like an immersion idea of a 4th dimension. Now, when you start thinking about 4th dimension in terms of geometry, I want you guys to think of something like this. If you take a 3-dimensional cube, I know you guys have probably all drawn something like this at some point in time. Have you guys all drawn that before?
Yes.
Yeah.
Now take that and turn it inside out. That's the 4th dimension. 4th dimension is when you take something and you turn it inside out of itself. Watch, let me show you this. This is really cool. This is really cool. Let me pull this up. What's that?
Oh, I wasn't paying attention.
Oh, did it? Oh, the markings came off. I'm trying to fix it.
Oh no, look what you did.
So, points don't have dimension. There's a place in space. Nothing crazy. I know you guys have all worked with that. How many points do you need to make a line? 2. And that's where we start going into here. Lines you need is defined by 2 points. Two points determine a line. Now, you need 2 points to determine determine a line to show what direction the line is moving. Do lines stop? Lines are continuous. We call that continuous in both directions.
Mine's
Yeah, one of these days I'll get it to stop. Whatever. So lines, lines are drawn with arrows. The arrows show continuous. They are continuous. In two directions. Yeah. Just throw it over there. Don't throw it, but throw it on the, put it in the back. The desk of mess. You can walk over there, right? Thanks, you're the best. Somewhere in this one. Thank you. So it goes it's continuous in two directions. If something in math is continuous and never ending, what do you call that? It's infinite. It goes on through infinity. Now, when we say something is infinite, do you know what that shape is? It's what? No. It's the infinity sign, but if you look at it closely, shouldn't you be hungry? What is it? It's a Pringle, yeah. It's a Pringle. It's a Pringle. It's a Pringle. Now, here's the deal. A Pringle is what we call a hyperbolic paraboloid.
Man, you can't tell us you can't eat your plastic.
It's called a hyperbolic paraboloid. Now, why, may you ask, that they came up with the idea of using what's called a hyperbolic paraboloid for Pringles? Well, the guy that invented this stuff, not like math, but that came up with the idea for the Pringle, was a math person that didn't like broken potato chips. As you can attest, chips break. He didn't want a broken chip. So he thought that, you guys all know that in nature and building, an arch is one of the strongest forms that you can have. You build with wedges and you have one of the strongest forms you can always have is having an arch. Well, a hyperbolic paraboloid is what we call a conic section. We don't even deal with that stuff in Algebra 2 or pre-calc, but it's just one of the shapes that's out there. And it has, it's strong and it's very rigid, and that's why they're able to stack on top of one another. Now, don't get me wrong, I know that every once in a while you're going to get a broken Pringle. That happens, but there are less broken Pringles in a can than there are broken chips in a bag. Right? So the guy that decided to do this made a press to make potato chips so he can stack them and not have broken chips. A little bit of more information that you just wish you knew before. You're welcome.
Thank you.
Lines. When we label lines, where they're labeled again via the point, so we'll call this B, C. They're labeled with capital letters. When we say we have a line, we would say, hey, this is line BC. And then what we do above that, we have to put the double arrows. The double arrows above them show that the line continues through point B and through point C, going in both directions. You guys have all done that before, I'm assuming, right? This is obviously not a line. This would be called a segment. Yeah, a line segment. And we'll talk about those in a little bit. There's one other way that you can sometimes see lines written out. Sometimes they will use a lowercase cursive letter, line L, line M. That's one of the few times we use cursive still for something. It's not as common, but sometimes they use that when you're in a diagram just for space. They save some space that way. And then lastly, we have the plane. The plane.
Oh, I like the picture.
Thank you.
Really? What if it, wait, it's gonna bounce. No, that doesn't make sense because it would crash. Oh my God.
plane, oh, sorry, I forgot to say this about lines. Lines are one-dimensional. I'm sorry, not one-dimensional, they're one-dimensional. A plane is a two-dimensional. Are you okay if I just write 2D for a plane? We all know what that means then? Because we start to get into 1D, 2D, 3D, all that kind of stuff. A plane is two-dimensional. It is a flat surface that extends in all directions infinitely. I think I spelled that wrong. So I'm going to say infinitely.
No.
A lot of times when people draw a plane, you can draw the plane that I had up there if you want, but it's not going to help you very much. The more common approach to drawing a plane is that we draw a parallelogram. Yeah, if you squint, it looks a lot better. A parallelogram, and then think about the idea of your paper. Your paper is a plane. The wall is a plane. The whiteboard's a plane. The ceiling's a plane. The floor is a plane. It extends out. If it extended out in all directions infinitely, it would just be a very, very, very big plane. It's flat. Things don't roll. Hopefully, when you drop stuff on. The way that planes are what we call determined, you need. We need three what are called non-collinear points to determine a plane. Non-collinear, that's a new word. If we look at the word non-collinear, what do you think the prefix of non stands for? Not. I say. What do you think linear stands for? Line. Now we just got to figure out what this prefix co is going with. Are we, let's say we're all working in the same place and we're all working in the same room. Aren't we all co-workers? So we're all working together. So not same, we're doing the same job. Co-workers, all teachers, we're all co-workers. This is not same line. That's what non-collinear stands for. Non-collinear just means not on the same line. Whereas collinear means same line. We use these two terms a ton in geometry. We use them a lot, so you'll see the collinear, non-collinear pretty often, okay? So we need to have what are called three non-collinear points to show that they are a plane. Because if they were three collinear points, what would they create? If they were collinear. A line, very good. They would create a line. Three collinear points would be on a line, but not necessarily a plane. Okay? So that's how that one works. Again, when we have the labeling of these, they're points. So if this is X, Y, and Z, we would say that this is plane with capital letters X, Y, Z. Or sometimes they write it out with a small parallelogram again. And then the only other way is sometimes they use a capital cursive letter. I don't know if that's a K, but it looks close enough to me. How about this? They use a capital letter with a lot of curves and frills to it. And it looks cursive-y. Cursive-ish. I really do try to make this somewhat enjoyable. I'm sorry if it's that bad.
That's what I'm sure it's wrong. And nobody asked me.
Not too bad. Segments, lines, and rays. Which one of those is a line? Which one?
Why?
But don't they all have 2 points? What do you want to say? What are on the ends?
Arrows.
The arrows, very good. That's what I was looking for. Thank you. So this one is our line. If I call this line, how would you label that? Line AB, what do you put over the AB?
Line.
Oh my gosh. No, don't ever do that.
Throw the double arrows over the top. Okay. Is line AB the same thing as line BA?
No.
Yes, it is. Directionality does not play any part or any issue to lines because they continue in both directions infinitely. It's more accustomed. It's something you're going to see a lot more prevalent as we're reading things. We read from left to right. So you usually see the first letter that you see from the left going over. That's just how it works. What do you think the second shape is, or second picture? What is it? Yeah. A drop of golden sun?
Did it?
Me? Wait, a name I call myself? Fa? T?
No, it's.
La? I don't know. Anyway.
Another color so.
Wait.
It's like what? It's
Doe is a deer. It's a female deer.
Yeah.
Ray is a drop of golden sun. Me, a name I call myself.
What?
Fa.
You've never said it.
You're like, why did I sign up for this junk? Okay. I'm an idiot sometimes. Hey, we're singing Do, Re, Mi, Fa, Sol, La, Ti, Do.
Oh, it's
That I'm an idiot? So, if I want to say that it's ray CD, where's the end point to the ray? C. The end point is the one without the arrow. It starts at one spot and goes through D. So when I label this one, the first letter will always be where the end point is. The second letter will always be where the arrow goes through. Now, what I want you guys to see here is that sometimes, obviously, rays can go the other direction. So if this is J and K, I wouldn't say this is ray JK. I would have to say this is ray KJ because you always put the endpoint letter first with a ray. No matter which way the ray is pointing, the first letter you write is always the endpoint. That way, if you don't have a picture, and I say, hey, you have ray LM, you know what to put first, the L. And then it goes through M. That's all. That's the reason for it. Also, as we get into angles, angles are two rays that are put together with the same endpoint. So that's kind of the other reason why we do this that way. Okay. So ray CD will not be the same as ray DC because it doesn't exist. And then the last one, obviously, is our segment. We'll call it EF. When you write down a segment, it's just the two letters for the points with a bar over it. No arrows, no points, no nothing. Again, if you keep in the idea of writing the first letter first, it just makes it easier. That's all. Ray EF is the same thing as ray, not ray. Segment EF is the same thing as segment FE. It's just going different directions. The distance from here to the computer is the same thing as from the computer here. This wall to that wall is the same as that wall to this wall. here to the wall is the same as the wall to here. Top to bottom is the same as bottom to top. Left to right, same as right to left. And I did that.
You'll get yelled at.
No, I did that to go facing you. I put it the right way. I'm proud of myself. Oh, I don't have any time. All right. Let me give you guys a couple of problems to work on here. I didn't get fully into this. That's fine, because I want you to try and visualize a few things on your own. What I did here was, instead of this time having you guys do the worksheet off the computer, this one's a good one that I want you to have on paper, so that way you can see the things better and use your pencil to help figure out what you're looking at and how things are interact. Plus, you can draw things better. So on this one here, I want you to do all of them, but skip number 13. Okay? It winds up being like 16 questions, but the first 8 of them are yes or no. It's really, really, really easy. Oops.
Really? How many questions did you say it was?
It's like 16. It's really fast. It won't take long. This is one of the easiest assignments ever. Yeah, it's all for you guys in here, because there should be some spares if we stop hogging them all and passing them around.
Why did you pass that? Sorry.
So again, you got spares? I get lazy and I don't count our card. Yeah, there's absolutely no reason that you guys there's no reason you guys need to label out 12 different rays. That's just stupid.
Whoa.
What?
No. She wants to touch your papers.
You guys We'll go through those. Pay attention to a couple of these things in here. We didn't really talk a ton about intersection. Oh, you got the wrong one. I'm sorry. Yeah, you're right. I'm sorry.
She is wrong.
Oh, yours is right. Sorry about that. I normally put a different sheet of paper between the two different worksheets that I'm looking at, and I forgot to put one in. All right. So, like I said, what's that? Co-linear, we just talked about that. Actually, you got it wrong. Yours is right. Yours is 1-1, says 1-1, 1-1, 1-1. Now, one of the things in here that you'll read about is something called the intersection. Obviously, intersection is just where two things run into each other. So what I want you guys to be able to do is start to visualize. What will... May I steal yours real fast, please? Yeah, your pencil. I'll give it back, maybe.
Maybe.
This is a plane, isn't it? Can I call a pencil, with the eraser being the end point and where the lead goes to, a ray? Wouldn't this be a pencil that intersects a plane at only one point? Wouldn't this be a ray that intersects a plane at all points?
No.
Yes, because the ray lies within the plane.
See, that's why I filled that. I ain't ready to do this.
I want you to think through some of these things. Now, one of the other advantages I would say to you guys is look in the book, has great pictures. See you guys.